for just 5 seconds. Imagine a world without electricity for only 5 seconds. There will be no hospitals, no internet, no clean water pumps, no industries, no modern education. When the power goes out, life changes within seconds. Fans stop, water pumps stop, students studying for exams study to continue under candlelight. Every time we flip a switch, we expect light to appear instantly. We rarely stop to ask what made that moment possible. Behind that simple click lies one of humanity's greatest engineering achievements: a vast network of generation, transmission, and distribution. Michael Faraday was once asked what practical use electricity had. He replied, "Why, sir, there is every probability that one day you'll be taxed." 2 centuries later, electricity powers hospitals, industries, education, and nearly every aspect of a modern civilization. Electricity is invisible, yet it powers almost every visible achievement of humanity. My name is MD Naif Washit Nishan. My journey began in Bangladesh, a country shaped by rivers, monsoons, and resilience. Growing up here, I witnessed both the incredible beauty of nature and the challenges that millions of people face every day. One challenge in particular stayed with me: arsenic contaminated groundwater. When I was a child, I once visited the house of my grandparents and witnessed the water there were contaminated by arsenic. As a child, I could not understand how something as essential as water could also become a threat to people's health. That made me ask a simple question: why can't science transform problems into opportunities? Around the same time, another moment sparked my imagination. I watched Spider-Man 2, where the main antagonist, Dr. Otto Octavius, unveiled his fusion experiment and said, "The power of the sun in the palm of my hand." At that age, it sounded like pure science fiction. Today, I see it differently. To me, it represents humanity's endless pursuit of cleaner, safer, and more sustainable sources of energy. Those two experiences, questioning the challenges around me and being inspired by the possibilities of science, shaped my curiosity. They inspired me to pursue engineering, not simply to understand how technology works, but to contribute to technologies that can improve people's lives. My academic foundation was built at Borishal Cadet College, a military-backed government high school where I studied from 2017 to 2023. The college instilled in me discipline, resilience, and the habit of striving for excellence. I graduated with a GPA of 5 out of 5 in both my SSC and ASSC examinations, earned the Government Talent Pool Scholarship, and secured the third position in the Borishal Education Board in both examinations. To prepare for an international engineering education, I also achieved a TOEFL IBT score of 105 and an SAT score of 1350 while continuously strengthening my foundation in mathematics, physics, and sustainable energy. My education extended far beyond the classroom. At Bristol Cadet College, I learned that leadership means taking responsibility. I served as a house prefect and dormitory prefect, helping lead my house to its first championship in 9 years. Outside academics, I actively participated in mathematics and physics Olympiads, scientific innovation projects, debate, public speaking, and cultural activities. I also volunteered in flood relief programs and educational outreach, experiences that taught me that engineering is ultimately about elevating people's quality of life. These experiences strengthened my leadership, communication skills, teamwork, and problem solving skills, qualities I hope to bring to the ITB community. One of the biggest decisions of my life was choosing engineering over other career paths. I qualified for a commission in the Bangladesh Navy and also earned admission to a government medical college. Both were respected and secure career paths. But I asked myself a different question: where can I create the greatest long term impact? I realized that electricity is the foundation of modern society. It powers hospitals, clean water systems, industries, schools, and every technology we rely on. That's why I chose electrical power engineering. My goal isn't simply to generate more electricity, it's to build smarter, cleaner, and more reliable energy systems that improve people's quality of life. For me, this wasn't just choosing the easier path, it was choosing the path with the greatest purpose. After deciding on my field, the next question was, where should I learn? Indonesia and Bangladesh share many of the same challenges. Both are delta nations facing rapid urbanization, climate change, rising energy demand, and the need for resilient infrastructure. Indonesia has also become one of Southeast Asia's fastest growing engineering and clean energy hubs, with major investments in smart grids, electric vehicles, battery industries, and renewable energy. By studying here, I won't just learn advanced engineering. I will learn how a neighboring country is solving challenges that Bangladesh also faces. My goal is to bring those ideas home, adapt them to our context, and strengthen regional cooperation for a more sustainable future. Among Indonesia's universities, Institute Technology Bandung stood out immediately. ITB is more than a university. It is where engineering, research, and national development come together. For decades, it has produced many of Indonesia's leading scientists and engineers. The electrical power engineering program offers exactly what I'm looking for: a strong theoretical foundation, hands-on laboratory experience, and opportunities to work on real-world energy challenges. I want to learn in an environment where innovation is not just studied, but applied. The knowledge and experience I gain at ITB will prepare me to contribute to a cleaner, smarter, and more resilient energy future for Bangladesh. After carefully evaluating the available programs and reflecting on my long term aspirations, I have selected the following three study programs that best align with my vision. My first choice is electrical power engineering because I believe a sustainable future begins with reliable, intelligent, and resilient power systems. I want to contribute to the development of smart grids that can integrate renewable energy efficiently and securely. My second choice is electrical engineering. It will strengthen my knowledge in power electronics, intelligent control systems, embedded technologies, and automation, providing a broader engineering foundation for solving future energy challenges. My third choice is metallurgical engineering. As the global transition to clean energy accelerates, sustainable metallurgy, critical minerals, and advanced battery materials will become increasingly important. Understanding these materials will complement my interest in modern electrical power systems and the broader energy transition. Together, these three programs represent my vision of combining energy, intelligent electrical systems, and advanced materials to build a cleaner and more sustainable future. People often think generating electricity is the hardest part. In reality, that's only the beginning. The real challenge is transmitting, balancing, storing, and delivering electricity safely and efficiently to millions of people. A single power grid connects renewable energy, hospitals, factories, schools, and homes. When that grid is reliable, society moves forward. When it fails, everything stops. That is what excites me about electrical power engineering. It combines mathematics, physics, and technology to solve problems that directly improve everyday life. I want to help build cleaner, smarter, and more resilient power systems that make sustainable development possible. My vision doesn't end with earning a degree, it begins there. At ITB, I want to build a strong foundation in electrical power engineering, participate in research, and learn from Indonesia's remarkable energy transition. After graduation, I hope to gain practical experience by working on real world power systems and collaborating with engineers across the region. Ultimately, I want to return to Bangladesh and apply that knowledge to modernize our energy infrastructure, support clean energy development, and help educate the next generation of engineers. For me, success is not measured by where I study, but by the positive impact I create after I return home. Looking beyond my undergraduate studies, I want to focus on research that makes clean energy more reliable and accessible. My interest includes smart power grids, energy storage systems, and intelligent grid management that can efficiently integrate renewable energy. I'm particularly interested in developing technologies that make electricity more stable, affordable, and resilient for developing countries like Bangladesh. My research goals are closely aligned with the United Nations Sustainable Development Goals, especially affordable and clean energy and climate action. I hope my future work will help build energy systems that not only power homes and industries, but also create a more sustainable future for generations to come. Engineering is often measured in megawatts, voltage, and efficiency, but I believe its true measure is much simpler. It's the number of lives made safer, the opportunities it creates, and the future it makes possible. I hope to begin that journey at Institute Technology Bandung, learn from Indonesia's remarkable engineering community, and one day return to my home to build a cleaner, smarter, and more resilient energy future for Bangladesh. Because every time someone flips a switch, they should never have to wonder whether the light will come on. Scientists study the world as it is, engineers create the world that never has been. I would like to end with a quote from Nikolai Tesla. I quote, "The present is theirs, the future for which I really work is mine." I unquote. Thank you for your time and consideration.